Hello, I'm Damla, and I will introduce GenASM. Read mapping is the first key step in genome sequence analysis where we align each read to the reference genome. Multiple steps of read mapping require approximate string matching or ASM to account for the sequencing errors and genetic variations. However, it is currently bottlenecked by the computational power and memory bandwidth limitations of existing systems. Our goal is to design a fast and flexible framework which can accelerate multiple steps of genome sequence analysis. We propose GenASM, and we base GenASM on BiTAP, an ASM algorithm that uses only fast and simple bitwise operations, making it amenable to efficient hardware acceleration. We modify BiTAP to support long reads and to enable parallelization. We also develop a novel BiTAP-compatible algorithm for traceback, and we co-designed specialized hardware for both algorithms. Our co-designed hardware consists of two components, GenASM DC and GenASM TB. GenASM is flexible and can be used for a number of use cases. In this work, we evaluate three of them: read alignment, pre-alignment filtering, and edit distance calculation. In our paper, we also briefly discuss several others. We find that for all the three use cases, GenASM is significantly more efficient in terms of both speed and power consumption than state-of-the-art software and hardware baselines. Thank you.